Hello everyone, welcome to my channel GVS Chem. In this module, let us discuss the measurable properties of gases in the chapter States of Matter. Please subscribe my channel, like, share and comment my videos. Measurable properties of gases. Measurable properties of gases are mass, volume, pressure and temperature. Measurable properties of gases are mass, volume, pressure, temperature. Now let us discuss about each of these properties in detail. Mass. Every substance has mass. Every substance has mass. How do we find the mass of a gas? Mass of a gas. See, we know that gases do not have definite volume and shape. Therefore, whatever the amount of gas present in a container, and if we find the mass of the container, then we can find the mass of the gas. So, mass of the gas equal to mass of the container minus mass of empty container. Mass of empty container. Right. In general, mass of a gas is measured by taking the number of moles. Therefore, mass by molar mass. Mass by molar mass equal to number of moles. Therefore, N equal to W by M. N is the number of moles, W is the mass of the gas, M is the molar mass. Now let us discuss the volume of the gas. Volume is the space occupied by gas. Space occupied by the gas. Under a given set of conditions. Given set of conditions means temperature and pressure. So at normal conditions of temperature and pressure, whatever the space occupied by the gas, that is called volume of the gas. So in general, in open spaces, gas occupies available space. Units of volume. Volume can be measured in terms of meter cube, centimeter cubes, liters, etc. So, meter cube, 1 meter cube. What is the volume? Formula for volume? Volume equal to length into breadth into height. So, 1 meter cube equal to 1 meter length into 1 meter breadth into 1 meter height. This is nothing but 100 centimeter into 100 centimeter into 100 centimeter equal to 10 lakh centimeters equal to 10 to the power 6 centimeter cube. 1 meter cube is also equal to 1000 liters. 1000 liters are 10 to the power 3 liters. Or it is also equal to. Now let us discuss about the pressure. This is a closed container and in this gas is there. So the gas molecules collide with each other. And with walls of the container. The force experienced by the walls of the container. Container means in which the gas is kept. Container. The force experienced by walls of the container is due to the bombardment of the molecules. Bombardment means dashing. bombardment of molecules of gas on walls of the container. So this outward force means as molecules bombard on walls of the container, this force is shown outside. Therefore, this outward force per unit area is called pressure. Now let us derive the units of pressure. So pressure equal to force by area. What is force? But force equal to mass into acceleration. F equal to ma. What is a? Acceleration is nothing but rate of velocity. So acceleration equal to velocity by time. F equal to ma. M into v by t. So what is velocity? Velocity equal to distance traveled by time. So d by t. Therefore, finally, F equal to m into velocity d by time, and of course already time is there. Therefore, force equal to mass into distance by time into time. Force equal to mass into distance by time into time. Let us keep the units for all these. Unit of mass is kg, unit of distance is meter, unit of time is second into second. Therefore, this is a SI unit. Therefore, SI unit of force is kilogram meter second minus 2. And of course, this kilogram meter second minus 2 is called Newton. Therefore, SI unit of force is Newton. 1 Newton equal to 1 kilogram meter second minus 2. So this is the unit of force. Now what is the pressure? Pressure equal to force by area. Force is SI unit of force is Newton. SI unit of area is meter square. Therefore, this is Newton per meter square. So SI unit of pressure is Newton per meter square, and it is called Pascal. It is a Pascal. Unit of pressure is Pascal. So 1 Pascal equal to 1 Newton per meter square, or 1 Newton meter minus 2. How do we define the Pascal? If a force of 1 Newton acts on an area 1 meter square, then pressure is called 1 Pascal. Right. Now Pascal is the smaller unit. The bigger unit of pressure, kilopascal. So 1 kilopascal is equal to 1000 Pascal. 1 kilopascal, the bigger unit is 1000 Pascal. For expressing the pressure of these gases, even kilopascal is also very small. Therefore, for gases, Pascal or kilopascal are very small. Therefore, a bigger unit of pressure is 1 bar or 1 atmosphere. 1 bar or 1 bar equal to 100 kilopascal is equal to 1 lakh pascal or is equal to 10 to the power 5 pascal. Now let us see the relation between bar, atmosphere, pascal, etc. So 1 atmosphere equal to 1.01325 bar. 1.05325 1.01325 bar is equal to 1.01325 into 10 to the power 5 pascal. So this is the relation between atmosphere, bar and pascal. Or otherwise, 1 bar equal to, so let us express bar in terms of atmosphere. 1 bar equal to 0.987 atmosphere is equal to 10 to the power 5 pascal. We know that Earth Earth is surrounded by a thick blanket of air. This is a blanket of air up to certain height. So this is called a thick blanket. The blanket of air around Earth is called atmosphere. So the force experienced by Earth at any area by a weight column of air is called atmospheric pressure. Now, how do we measure the atmospheric pressure? Now, let us know how to measure the atmospheric pressure. So, measurement of atmospheric pressure. Atmospheric pressure is measured by using an instrument known as barometer. So, different varieties of barometers are there. Let us discuss here mercury barometer. Mercury barometer. How do we construct this barometer? So this is a dish of mercury. And of course here this is a column. This is a glass tube. This is a glass tube of 1 meter length, closed at one end. 1 meter length closed at one end. And of course, fill this 1 meter glass tube with mercury and invert into the mercury dish. So this is mercury dish. So when we invert this glass column of 1 meter length filled with mercury inverted into this glass trough, the mercury falls down and stands still at a certain level. So this is the column of the mercury. So this column height is generally 76 centimeters at the sea level. This length of the mercury is 76 centimeters at the sea level. Now let us calculate the pressure. Calculation of pressure. So what is pressure? Pressure is nothing but pressure equal to downward force of Hg column by area of cross section of mercury column. So this is equal to, downward force is nothing but mass of mercury column into acceleration due to gravity by area of cross section of mercury column. Mass of mercury column is nothing but m, and the acceleration due to gravity is g, mg by, this is a, mg by a. Now, mass of mercury is equal to volume into density, but volume equal to area into height density. Area is a h d, ahd. Thus, pressure equal to this is area, this is mass of the mercury, ahd, into acceleration due to gravity g by area of cross section a, this is nothing but hdz. Since density of mercury is fixed, constant, acceleration due to gravity is also constant. Since density and acceleration due to gravity are constant, therefore pressure, that is atmospheric pressure, depends on mercury column. According to international agreement, standard atmospheric pressure is the pressure exerted by exactly 76 centimeters of mercury column. Pressure exerted by exactly 76 centimeters of mercury column. So, 1 atmosphere equal to 76 centimeter is also equal to 760 mm of mercury. This is equal to 760 torr. Another unit of pressure is torr. So this torr unit is taken in honor of the Torricelli, a scientist who is responsible for the construction of a barometer. Manometer is an instrument used to measure the pressure inside the container. When there is no pressure, the manometer has equal levels of mercury on either side of the tubes. Therefore, the pressure of the gas equal to atmospheric pressure. Keep the point in mind that atmospheric pressure acts here and the pressure of the gas acts here. If the gas in the container exerts the pressure, then mercury level on this side comes down. Automatically the mercury level goes up here. Therefore, there is a difference in mercury levels. Now the pressure exerted by the gas is equal to, that is pressure of the gas equal to atmospheric pressure plus pH, that is the mercury column. Whereas if the atmospheric pressure is more than the pressure exerted by the gas, then the mercury column comes down here, whereas on this side, that is the container side, mercury column goes up. Therefore, the pressure of the gas equal to atmospheric pressure minus pH, that is mercury level. Manometer is an instrument used to measure the pressure inside the containers. Manometer has mercury inside. So the manometer with mercury is difficult to carry from place to place. Therefore, nowadays pressure gauzes are used. You might have seen as a daily experience, that is, tires of the vehicles are inflated, and before filling the tires with air, the mechanic measures the pressure of the air inside the tire. So that is pressure gauze. So these pressure gauzes are portable and easy to carry. So pressure gauze, it is portable and easy to carry. Easy to carry because it doesn't have mercury. Moreover, it does not work. It does not need electricity to work. It does not need electricity, power to work. Therefore, pressure gases are very convenient to measure the pressure of the gases inside the container. Now let us see the applications of pressure gas. Pressure gases are used to measure the pressure of the liquids, vapors, solids and gases. Pressure gases are used for the inspection of air brakes on trucks. Pressure gases are used in chemical, petrochemical, sanitary, pharmaceuticals and process industries. Pressure gases are used in HVAC, refrigeration, ventilation, food and beverage industries. Pressure gases are also used in eliminating the potential leak paths. Now let us have another instrument. A piezometer is a type of manometer that is designed to calculate the medium pressure range of liquids. Now let us discuss about the temperature. The degree of hotness or coldness of a body is called temperature. Temperature can be measured in terms of effect its change produces on other measurable properties such as expansion of objects. Temperature is measured by using an instrument known as a thermometer. Thermometers contain mercury as a liquid. Temperature can be measured in terms of the effect that its change produces on other measurable properties such as expansion of objects. In thermometer, mercury is used. Mercury is a suitable liquid to use in thermometer because it does not stick to the glass. Its expansion is uniform. Now let us see the different scales of temperature. There are three scales of temperature. One is absolute scale or Kelvin scale, and the other one is Celsius scale or centigrade scale, and the next one is Fahrenheit scale. In these three scales, there are minimum temperature, that is the boiling point and melting point. Boiling point and melting point. So here in a Kelvin scale, the melting point of ice is 273.15 Kelvin, whereas a boiling point of water is 373.15 Kelvin. In a Celsius or centigrade scale, 0 degrees is the melting point of ice and 100 degrees centigrade is the boiling point of water. Whereas in Fahrenheit scale, 32 degrees Fahrenheit is the melting point of ice, whereas 212 degrees Fahrenheit is the boiling point of water. Now let us do a small problem based on the conversion of one scale to another scale. So here, the problem is convert 122 degrees F into Celsius scale. So here in a Celsius and centigrade scale is 100 degrees centigrade is equal to, here boiling point is 212 minus melting point is 32, so this is equal to 180 degrees F. Now the formula is centigrade scale equal to 5 by 9 into F minus 32. So here Celsius scale equal to 5 by 9 into F. Fahrenheit degree centigrade given is 122 minus 32. So here 9C is equal to 5 into 122 minus 32. How much this is? 90. So 9 here 10 times. Therefore degree centigrade equal to 50 degrees centigrade. Thus 50 degrees centigrade in Celsius scale is equal to 122 degrees Fahrenheit scale. Please subscribe my channel, share and like my videos. Thank you.